My dear students, welcome to chemistry class। हम लोग पिछले वीडियो में ऑस्मोटिक प्रेशर, हाइपरटोनिक सॉल्यूशन एंड हाइपोटोनिक सॉल्यूशन स्टडी किया था। अब हम लोग स्टडी करने वाले हैं रिवर्स ऑस्मोसिस। रिवर्स ऑस्मोसिस। So let us see what happens in reverse osmosis. You might have seen RO in your home. It is based on the principle of opposite to osmosis. In reverse osmosis, solvent flows from higher to lower concentration side. If the pressure applied on the solution is greater than osmotic pressure, then the solvent starts passing from solution into solvent. This is called reverse osmosis. Reverse osmosis. In short, it is called RO. Reverse osmosis. If the pressure applied on the solution side, to understand reverse osmosis, we can draw a plot. Here is the one chamber, and here is pure water, and here is saline water. Saline water. Now it is semi-permeable membrane, SPM, semi-permeable membrane. If the pressure is greater than osmotic pressure, then the solvent starts passing from higher to lower. It is called reverse osmosis. Pressure greater than osmotic pressure, then the direction of osmosis is reversed. If pressure is greater than osmotic pressure that is pi, then the direction of osmosis is reversed. It is used for purification of seawater or hard water. It is used in the purification of seawater. Seawater contains many dissolved salts: calcium chloride, magnesium chloride, even sodium chloride. Sodium chloride is in largest quantity. Seawater is saline, and therefore the salt dissolved in seawater can be separated by an apparatus called desalination plant. It is a big plant which involves a removal of salts and separation of pure water from saline water. If the pressure applied on the solution is greater than osmotic pressure, then the solvent starts passing from solution into solvent. If the pressure applied on the solution side is greater than osmotic pressure, then solvent starts passing from solution to solvent side, solution into solvent side, into solvent. It is called reverse osmosis. This is pure water, so water is removed from the solution to the solvent. Here is low concentration, and due to salt, saline water is highly concentrated. Seawater generally contains 3.5% dissolved salts, out of which 2.8% is sodium chloride. Calcium and magnesium chloride are deliquescent, are contaminated along with the sodium chloride. Now we will study Wundt's half factor. And there is also some differences between diffusion and osmosis. In diffusion, no semi-permeable membrane is required. Diffusion is shown by gases, liquid and solution, but osmosis is shown by solution only. In diffusion, both solvent and solute molecules move in opposite direction, but in osmosis only solvent molecules move. So this is the distinction between osmosis and diffusion. Now we will study Wundt of factor. Wundt of factor, and it is denoted by I. Wundt of factor is denoted by I. I is control. It is the ratio of normal molar mass by observed molar mass. Normal molar mass by observed molar mass. Observed molar mass means the experimental, the molar mass that is obtained by an experiment, which is equal to total number of moles after association or dissociation divided by total number of moles before association or dissociation divided by total number of moles before association or dissociation. Observed colligative property by normal colligative property. It is also equal to observed colligative property. Observed colligative property. It is the ratio of observed colligative property by normal colligative property. Normal colligative property. Colligative property. So Wundt of factor can be defined in terms of normal molar mass and observed molar mass. I is the ratio of normal molar mass and observed molar mass. Observed molar mass is experimental. So the calculated molar mass by experimental molar mass gives the value of Wundt of factor. Either this formula can be used or this may be true. Now we will study association and dissociation case. So why what is the meaning of association and dissociation? Association. We take example of acetic acid, CH3COOH. Here, two molecules of acetic acid undergoes dimerization, CH3COOH, whole 2 is produced. It is dimer. So number of particles are reduced here. So I is equal to the number of particles 1 है, and before association it was 2. So I is equal to half, means less than 1. That is, I is less than 1. In case of dissociation, for example, CeCl2 aqueous, it is converted to Ce plus 2 and 2Cl minus aqueous. So I can be calculated. How I can be calculated? I is equal to 2 plus 1, 3 by 1. So it is I, therefore I is greater than 1. It is a case of dissociation and it is a case of association. When solute undergoes association or dissociation, abnormal molar mass results. Sometimes the molar mass obtained from the experimental measurement of a colligative property is higher or lower than the normal molar mass. That is according to formula. These are called the abnormal molar mass. This behavior is observed because of either association or dissociation of the solute in the solution. Molar mass is inversely proportional to colligative property. Molar mass is inversely proportional to colligative property. Inversely proportional to colligative property. So one question strikes that what is abnormal molar